Hello, Algebra. This whole week we're going to work on the quadratic formula, and this is lesson 9.6 out of your book. So today we're going to just talk about a part of it called the discriminant, and we will get through that, and then next time we'll actually use the quadratic formula. But I've learned that taking this step by step a little bit slower is very helpful to kids. So let's first start by just doing a quick review of what quadratics are. So what is a quadratic equation or quadratic function? So a quadratic equation or function is anything that has an x squared term in it, okay? So it can be negative 3x squared plus 4. You can have 2x squared. Oh my gosh, that didn't work. Minus x minus 1. Anything as long as you have an equal sign, I guess, in it. But as long as it has the squared, that's the part that makes it quadratic. What shape does the graph of a quadratic equation produce? So you should think of it as kind of a U or an upside down U, okay? And remember, they can be skinny, they can be fat, whatever. This is called a parabola. This next question is, what are some examples of this shape, so this parabola, in real life? And usually I have a pretty decent discussion on this in class, but since you're not in person, I don't get instant feedback. Some of the examples some people have said are like a fish jumping out of water or in the water kind of makes a parabola shape. A banana is the shape of a parabola. A satellite dish, a rainbow, bridges, anything that has that curved shape. So if you can think of something in real life that is the shape of a parabola, why don't you send me a quick email or something? And if it is one that I have never heard of from a student before, then I will give you a bonus point that you can use, just a +1 point that you can use on any assignment or test or anything. The next question is, what is the standard form of a quadratic equation? So hopefully you remember that that is your ax squared plus bx plus c equals 0. Okay? So a lot like this one that I wrote up here. Okay? And then how do we solve quadratic equations and how do we choose the best method? Well, we have talked about numerous ways to solve quadratic equations. Back in 9.1, we talked about how to graph. Okay? And then we did square roots and factoring. And then I believe in 9.5, we did completing the square. And now we're going to learn about the quadratic formula. And there's different reasons when you would use certain things. So factoring is usually quick and easy. And when the constant term is 0 or if the factors are easily determined, so if you have something like 5x squared plus 10x equals 0, right there, the constant term is 0, so you don't have that in there. So this is a great one to factor. You can factor the trinomials into groupies, and that's good. But the bad part about it is that not all equations are factorable. When they are, they're quick and easy. When they're not, then you have to resort to something else. So graphing is a way to find a solution, but remember that's only when an approximate solution is sufficient. You don't want to do that when you have decimals that need exact numbers. Using square roots, This can only be used if the equation has no x terms, so no bx right here. Okay? So that one would be something like 4x squared minus 16. Okay, there's no b term in that one. Completing the square, you can use that for anything, but it is easier when your a is equal to 1 and when your b is even. And lastly, what we're doing this week is the quadratic formula. And the cool part about the quadratic formula is that you can use it for any equation, no matter what. So my past students have always decided at this point if they like it or if they don't. Because you can do any of these other methods to solve equations, and they're usually a lot faster and less confusing, but the quadratic formula will always work no matter what. Okay? I'll give you a little sneak peek of the quadratic formula right here. So it's a little confusing, but it can be done, and we're going to step it through this week and figure this out. This sheet I had given you guys, this has it all filled out already, and this is just kind of a reminder on how to graph, how to factor into groupies, how to complete the square, and so forth. So I just threw that on here. Okay, that was my quick little review. We're going to go to the next page, and we're going to talk about standard form and the discriminant. And so we talked about standard form being ax squared plus bx plus c, and set that equal to 0. So your constants are your a, your b, and your c. And what you're going to do is you're going to pick those out. And that is the very first step in all of this. Well, the first step is to put it in standard form, and then it's to pick out your a, b, and c. So I'm going to go through this. If you want to at any time pause it and do it yourself and then play and see if you got the right answers, that'd be awesome. A in this case is 3 because a is whatever is multiplied to x squared. B is negative 2 and c is negative 5. Down here my a is 1, my negative 4 is my b, and my positive 4 is my c. Number 3, I need to put that one into standard form. So I'm going to subtract the 7 from both sides. So it looks like negative x squared minus 3x minus 7 equals 0. And now my a is going to be negative 1, my b negative 3, and my c negative 7. On this one, again, I have to put it into standard form first. So 5x squared plus 20, because I need to add 20 to both sides. And now my a is positive 5. My b is missing. There is no x term. So my b is 0. My c is 20. On number 5, again, I need to put that into standard form, so I'm going to write 9x squared. I need to add my negative 6x to both sides and add my 1. So my a is 9, my b is 6, and my c is 1. This one, I will rewrite it in standard form, negative 2x squared minus x equals 0. So my a is negative 2, my b is negative 1, and my c is 0. Now that we have the a, the b, and the c, all the constants identified, we're going to use the discriminant. Again, here's the quadratic formula. And the discriminant is just a part right in here. the discriminant, I'm going to use my highlighter if I can, is just the b squared minus 4ac. And that's special because it's going to tell us if there are 0 solutions, 1 solution, or 2 solutions. And these are just real solutions. So it depends on what you get when you do this discriminant, which is just b squared minus 4ac. Okay? You're going to plug in your b, your a, and your c, and whatever you get determines how many solutions. So if you get a negative number, here's their example. If they do that b squared minus 4ac and get a negative number, doesn't matter if it's negative 16, negative 2, negative 3,000, doesn't matter. If it's negative, that means you have 0 real solutions. Okay? Because this is what the picture of the graph looks like. It does not cross the x-axis at all. If you do b squared minus 4ac and you get a 0, then you have 1 real solution. That means that the vertex just touches the x-axis just once, and that's your only solution. And then if you do b squared minus 4ac and you get a positive number, okay, doesn't matter if it's positive 100 or positive 2/3, as long as it's positive, you're going to have 2 real solutions. So we already filled out our A, our B, and our C for all of these. So what we're going to do now is go through and find the discriminant and tell me how many solutions each of these have. So, all right. So remember, it's just the b squared minus 4ac, just a part of the quadratic formula, and we'll deal with the rest of it next time. But for now, we're just looking at the b squared minus 4ac. And all we care is if it's a negative number, a positive number, or if it is equal to 0. So let's plug these in. B squared, so I have negative 2 squared, minus 4 times a is 3, c is negative 5. So I have 4 plus, because I have negative 4 times 3 times negative 5. And you can just put these right on your calculator. And if you put the parentheses in the right place, you should be able to just type it in exactly like I have it in this line right here. So plus 60. So I get 64 when I plug this in. So that means my discriminant is 64, but how many solutions does that have? Well, 64 is a positive number, so that means I have 2 real solutions. Let's go through and do all of these. So again, it's b squared minus 4ac. So I have negative 4 squared minus 4 times 1 times 4. And that's 16 minus 16, which gives me 0. If this equals 0, that means I have 1 real solution. It might be a good idea to copy down this chart down here or something similar so you know how many solutions everything is, just in case you forget. Number 3, my b squared minus 4ac, my b squared would be negative 3 squared minus 4 times a, which is negative 1, times c, which is negative 7. I believe that gives me negative 19, which means it's a negative number, so there are 0 or no real solutions. 3 left. 0 squared minus 4 times 5 times 20. That's going to give me negative 400, which means there are no real solutions. Oh my gosh, pen's crazy. 6 squared minus 4 times 9 times 1. That one is going to be 36 minus 36, so I get 0, which means there's one real solution. And number 6 down here, my b squared is negative 1 squared minus 4 times negative 2 times 0. Well, this is just all 0, so 1 minus 0 is 1, so I have a positive number, so 2 real solutions. And this is exactly what your assignment will be like. I think there's about 8 problems set up just like this, where you will need to write out the A, the B, and the C, and then give me the number of solutions. And that's it for day 1. I think you'll be able to handle it. Let me know if you have any questions, and we'll see you again for day 2.